Hello. Hello, 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 hello. Okay.
Accelerator, the strongest level 5 aspect.
Okay. So it's Friday and we are here with another stream or problem solving and let me make a new file. Okay, just copy it, paste it. Okay, so where were we? We were here. Okay, so we were solving this problem, right? Maybe we. Okay, yes, money sums we solved it. Uh, okay. So this question. Mm, there is a list of n numbers and two players who move alternately. On each move, a player removes either the first or last number from the list, and their score increases by that number. Both players try to maximize their scores. What is the maximum possible score for the first player when both players play optimally? Okay. What is the maximum possible score for the first player when both players play optimally? Okay. Okay, so what is it? It is removal game. So we have an array, let's say 4 5 1 3. Okay, so we have two players, player 1, player 2. In each turn they can choose either the first element or the last element. Okay, and then the second player's turn will come and he will do the same, and they will do it optimally so that their score is maximized. So let's just try to simulate this one. So the first player here will choose 4 at the first because it will give him the maximum, or he can choose 3. There is the option, several options. Okay, second player will choose 5 since 4 is gone, so he will choose 5. Okay, then the first player will choose again 3, and second player will choose 1. So this is the optimal way, and I think this will give him 7 answer. What is the answer here? It's 8, so it is not the optimal. So there was one option. There was another option that player 1 would choose 3 first, then this guy will choose 4 again, then player 1 will choose 5, and this he will choose 1. So it will be 8 and 5. So yeah, this is the optimal answer. Optimal. This is the maximum score that the first player can get. So yeah, how do we define the DP state then? Okay, DP state can be like this. We have the endpoints of array, and right, we have the endpoints of array, and we can say that this will give me the maximum possible score of player 1. We need to have a turn as well. So how do we is this DP state correct? I think we need a turn as well, right? So 0 or 1, this will indicate the turn of the player, and in the end we can, or instead of that we can have a boolean for basically the player. So maximum possible score of player 1 for the player, we have a turn. We have a turn as well, which is a boolean of player turn. Yeah, something like this. Okay. So we'll start with 0 and n, or 1 and n, and player 1 will start. Okay, then we can have two options, right? Let's try to make the tree of this, basically deep tree or whatever, recursive tree. So we can either choose the first one. Okay, in that case it will be something like this: value of position 1 plus, we have to simulate for the second person's value, first person's turn, or we can do like this: value of the nth plus second person's turn, and we have 1 and minus 1 and 1. Okay, no, this will not work. Oh, okay. Let me just remove it. Let's start from the base case. Okay. So suppose we have only two values, right? Suppose we have only two values. So how do we go about solving this? Or let's say we have only one value. So how do we go about solving this? If our dv state is like this, then we have something like this, right? 1 1 and 0. In that case the answer will be 4 only, and it will be stored in yeah, this one, it will be stored here only. And if we have 4 and 5, in that case it will be 5. If we have 4 5 6, then we have to choose. We have two options. Either we choose the first one or the last one, and based on that we have to move in such a way that we do not count the score of the second person in our score. Okay. And so how do we do that? Something in transition only, I think. For example, if we have a recursive solution, then I can try to make the calls. That is, we'll have option. We'll have two options basically for the player one, and this will be basically we choose the first one, so it will be 4 plus the rest of the array. Cannot add it. Addition should not be. Sorry. So I was saying, we have the DP state, we have the DP, we have the base case, but we don't have transition yet. And I was thinking that for every player, not only we want to maximize our score, but also we want to minimize the other player's score, right? I was thinking in that direction also, but nothing significant that I've been able to come till now. Looks like in the first question itself we need to take some help. There's nothing coming to my mind for the transition. Remove king. So the only thing I read from there was that there is a difference of score that we need to consider here. So instead of scoring the player's score, we need to score the difference. Okay. So we have score 1. For player 1. We have score 2 for player 2. We know that S1 and S2 is going to be sum of array. So what player 1 wants to do is he wants to maximize S1 minus S2. Okay. And what player 2 wants to do is minimize this. S1 minus S2 or maximize S2 minus S1. So similarly, what is the plan here? This will be same. Okay, so we'll do some changes here. Okay, so dpij will now be storing the storing the maximum difference of player 1 and player 2 scores if the game was played from ith to jth element of array. So we want to maximize the difference, right? And we'll be storing the difference only. So how the answer will be calculated? Okay, so we have the maximum difference here. Okay, so if we will also have the sum here, right? We have this and we have this. So if you add both of these and divide by 2, so basically, and then this should give us our score, right? Okay, so for transition, similar to what we had for 4513, let me take this example, 4513 again. Okay, so we have two choices for base case will be same. Base case for okay. Base case will be same. So Okay, so there is uh, there are two ways for player one to choose the element or to increase their score. First they can choose this one or this one, right? So suppose if they choose this one, then the dp of let's say this is 1 and n. So dp of 1n will be nothing but uh, dp of 1n will be nothing but whatever value that we have chosen. Okay, and we want our score to be maximum. Let's not do this. Okay, so we have two options. Yes, suppose we choose the first one. So we choose the first value, and let's say we chose the second value. And since we are storing the difference, right? So if we choose this one, then the next pair will be having access to these elements only. So what is it? It is nothing but the answer to it is nothing but the answer of our problem, but from 2 to n. Basically it is dp to n only, right? And this will be the second pair's score because he is choosing from this, right? So yeah, and similarly here also if we choose this one, then second pair will have the access to 1 to n minus 1. So again this is score of player 1 and this is score of player 2. So if we are storing the difference here only, but since we have two choices and our objective is to maximize the score, so we have the option, we have to choose the maximum between these two, and then we'll store it into our dp. Okay, so this is a transition. Of course this is taken from this here because my lame mind could not come up with this. I am sure in the solution that I have submitted earlier, there was a smart way of doing this, and I have just forgotten maybe. So yeah, I think we are good to go, and let's just solve the problem. Okay, so we'll have a dp long since we are adding and the elements can be huge. Okay, dp, and it is 5001 and 5001 initialized with 0. Okay, elements are initialized with 0. Again we'll take input and we'll store the array in, let's say, val or something, and for need to write the macro really. Okay, done. And we are done with the input. So 4252, 4, 5 and 3. Okay, we'll just start the we'll just start with this, I guess. we'll go to n, and again we'll go to n. Okay, and if we encounter that I and j is equal, then simply we'll do dpij is I think this will go from I. This will be value of I. Okay. Else we have two options, right? dp of ij, either we take the first element maybe we should not start with 0, and I don't think we'll be yeah, we'll start with 1. Okay, so value, and we want to maximize the difference, so this will be I plus 1, and but since it is bottom up solution, maybe we'll start from I is equal to n, go to I greater than 0. So we'll start from the last element, so I and j will be here, and for this the answer will be 3 only. Okay. Let's just see what happens. And here we have what? J, since j is the right limit. And we'll have again while I dpi j minus 1. And our answer will be course, I have made a mistake somewhere. Wait, isn't this the same thing? Okay, it's the same thing, no? Yes, it's the same thing. No, wait, wait. Yeah, okay. Oh, sorry. What is the difference between this code and this code, aside from the indexes? Mm-hmm. Okay. Okay. I see what is wrong here. Damn. Such a silly mistake. I'm getting dumber day by day. It's like it's like I'm solving problems without my brain present here. Let's see my order submission. Yeah, it's the same. Okay, let's go to the next question. Hmm. We have a question where we need to divide the set into basically number into two sets of equal sum. Okay. Number of ways to divide it into this. Okay. This one is simple. Two sets two. Okay. So we have given n is equal to 7. Okay, which means we have all these numbers, and we want to divide it into two sets. So it is what, 28. Okay, we need to divide the subset, basically these numbers, into two subsets each of some 28. So instead of finding two subsets, we can only search for one subset. If we can find one subset, that will indirectly mean that we have another subset that is equal to, sum of which is equal to 28, because we have only two subsets, right? So their sum individually has to equal, when added together, has to equal to the sum of the array. So yeah, we need to find only one subset here, and you can do that using subset sum. Alright. Since we are not going to include 0 here, so we can remove the special base case where you can have a 0 and sum is also 0. So there are two ways of making the subset. Okay. So dp state, it will be simple. dp of ij will be what? We don't need extra state, right? We need one. Okay. So the second state is basically j. What is it? It's basically the number of ways to divide in two subsets of sum j of sum j using first I elements. Okay, we have the state, we need the transition. Transition will be like, we have dp ij, right? So we need to check if the current I is less than equal to j. In that case, we can have dpij's as dp of I minus 1 j plus dp of I minus 1 j minus I. Okay, and else we have dp of ij as dp of I minus j only, or we can set this in the first hand, and then if it is true, and we'll just add it that end. Okay, so transition is here, and so what is the base case? Base case. Base case, sorry, again base case, we have 0 elements and 0 sum. What are the number of base? 1. Again, if we have 0 elements and some addition there is, and we have some summation, it will be 0, and if we have elements there, I mean this is not true, and also we cannot have this also. Since the number is going from 1, right? Since the number is going from 1, since the number is going from 1 actually, so this will be okay. I will do this one, and for this okay, actually this let's just put it here. There is some I, but there is no j. So the target sum is what? And this is also 0, right? Okay. Let's just implement it. Don't need this. We need mod. We need mod 500 and 500. Okay. So this will be 500 and okay. This is kind of a big number. 1 2 5 1 1 1. I hope it is correct. Yes, it is correct. 2 3 4 5 6 10 to the power 6. I'm not sure if the DP can. There might be a memory issue. But let's do this. No, there is no memory issue. I mean, there still can be because it is a 2D DP. Okay. We'll run a loop on 0 to n 0 to the sum. We don't want to use again and again, so okay. If I is double equal to 0 and j is double equal to 0, in that case our dpij will be 1. Else if I is 0, then dpij is 0. Else if any one of these is 0, then dpij is 0. Else dpij is dp I minus 1j, and if I minus j is greater than equal to 0, then dpij plus equal to dp I minus 1 j minus I, and we'll mod it. Okay. And in the end the answer will be in the sorry I think okay, we need to check also if n into n plus 1 by 2 is percentage 2. It's not 0, then we'll just see out 0 and return. Else else we can okay. Okay, so we have 7. Sorry. Memory issue, please. Damn. Third question. This is a new question. And my record with new question is very bad. There are n mountains in a row, each with a specified height. You begin your hang gliding route from same mountain. Okay. Okay. Acha, from some mountain, any one of this mountain. Okay, so on your route, okay, on my route, what is the maximum? Wait, on some mountain. Isn't this just the finding the maximum? Yeah, but if there are same. Okay, we cannot move from there to there. Okay, so there is a show. Find the tallest mountain. You move to either of the path. And if there is multiple, then it's kind of a greedy question, I think. Don't need this much memory. We'll input 10 and again vector and v. Auto ampersand I in V, we'll do C in I, and then we'll have a previous position, let's say 0. We'll go from the first mountain. Or rather maximum height mountain. We'll start from there and max. That's basically max element v dot begin v dot end. And for this have an answer. Okay, so if our mountain is the maximum mountain, okay, so in that case we have our answer as maximum of answer, and the current position minus previous plus 1. Why? If we have at 0 1 and the previous will be set to the current position. Okay. So here now we have the previous at 0. 1 2 3 4 5. So 5 minus 0 plus 1, that will be 6. But if we have 40 is here, plus 1 is not okay. But if we have our previous is here, let's say we have another 40 here, or let's say 40 is here, so the previous will be set to what? 0 1 2, and we have 1 2 3 4 5, or 1 2 3. Okay, so we can 1 2 3, so 0 1 2 3 4 5, 0 1 2 3 4 5. So 5 minus 2 3, but we only have 2 mountains visited. How many what is the maximum number of mountains you can visit on your route? Okay, so from 40 we go to 35, and from 35 we go to 20, and from 20 we go to 17, and then from 17 we go to 15. Or directly from 40 to 20. If it is the first encounter, in that case the answer is simply I minus previous. Other than that, we have I minus previous minus 1 and previous minus 2. And let's just output the answer. 5. I'm not sure if the answer is correct, but anyway, I'm going to submit it anyway. Let's go, let's go, let's go, let's go. All the answers are wrong. All the answers are wrong. Why is this incorrect? Let's dive into it. We have the maximum mountain here. What is the answer? Okay, we have the maximum mountain here, and but why do we have 7 as answer? From some mountain, right? So if we start from here, then we can go all the way up to here. Yeah, we can go all the way up to here. I'm not understanding the question correctly, I think. Maybe the answer here is that we start from here and go here, then here, then here. That won't work. Anyone if not understanding this question. I'm not sure I understand the problem. That is why I think I'm having a issue here. How is the answer in this one? 7. Maybe it is like cannot go from right to left. We can only go from left to right, maybe. If that is the case, then we will start from here. Okay, we'll go here, we'll go here, then here, then here. We can go from here, or we can go to here, or we can go here. Okay. The fuck is this one? Why are new questions all like that? I mean, it looks simple, but it is not. Right? I'm not sure if I got that solution. I mean, I'm not trying to. I remember that solution because I'm going to solve it on my own, similar with that other new question. But yeah, again. So let's try to solve it. So from here we can go to here. Then what is the maximum that we have? We can go to here. Okay, all the way up to here, and then we can go here, and then what is the maximum? We can go here, we can go here, we can go here. So 1 2 3 4 5 6 7. Oh, okay. Okay. Okay, I think it is like that. We have to traverse from mountain to mountain, not like one mountain to another mountain. Basically, we cannot have a prolonged flight. We need to take rest at like mountains. Initially all will be equal to 1 only. Yep, I'll solve it another time. Increasing subsequences. You are given an array containing n integers. Your task will determine the longest increasing subsequence in the array. That is the longest subsequence where every element is larger than the previous one. A subsequence is a sequence that can be derived from array by deleting some elements without changing the order of the remaining elements. 2 into 10 to the power 5. So no dp. We need to come up with a solution. That involves basically set, map, sorting, something like that. Longest subsequence. Okay, so if we have this and then this and then this, the longest subsequence will be this only. Okay, and if we have this again, so this will not be included in that. We have this, then this will be included. We have this, then this will not be included. This can be included. The answer will be 4. longest increasing subsequence. Okay. Okay. I have a solution in mind. I'm not sure if it is correct. Increasing subsequence. I have a vague memory of the solution I have submitted in the past. So based on that only I have this solution. I'm proposing this solution. So hear me out. Basically, we have this, right? We have this. So let's say we have a vector or a container. Maybe we have a container here that stores the longest increasing subsequence. Okay, so we are now at this point. We see 7, and of course since we have no element, we will just put it here. So we have 7. Okay. I need to get the length only. Okay, so we put it into here. Okay. Now we go to the next element. We see 3. But since we already have 7, this cannot contribute to the maximum subsequence. Increasing subsequence. This cannot contribute to the increasing subsequence where 7 is present, right? So what can we do? We cannot include 3 here, right? But if you notice, whatever sequence that S7 can be a part of it, and also it is an increasing subsequence. Basically, if there is a sequence that starts with 7 and it is an increasing subsequence, then for sure instead of 7 we can have 3 there, and that will also work, right? Since 7 is less than 3, 7 is greater than 3. So let's say we have 7, 8, 9, something like that. But in between we have 3, right? So this subsequence is valid, but also 3, 8, 9 is also valid, right? So we can just remove it from this container. So if we encounter a number that is strictly smaller than this, okay, strictly smaller, not equal to, we cannot have equal to because we have the condition here, right, that larger than the previous one. So if we have we encounter a number that is strictly smaller than the last number in the container, then we'll pop that one out and put this one in. But also we need to check whether we already have a number that is greater than that, because it can be the case that let's say we have 2, we have 7, and then we have 1, we have 1 here, right? So you can say that 7 is less than 7 is greater than 1, so let's pop 7 out and put 1 here. But if you see, 2 is already present there, right? So 2 is already present there, so instead of like putting 1 there, we need to we can remove 2 also and then put 1, but that will change the subsequence length, I think. So here let's try run this one and try to see what happens. We have 7, we encounter 3, we'll pop 7 out and put 3 in. Okay, again we encounter 5, so we encounter 5 now, so we have 3. Okay, so we move on to the next one. Now we have encountered 3. Okay, we check in the collection or container, and that if we have a element greater than 3 but less than this, right, greater than 3 but less than the last element. Wait, we can solve this using priority queue now. Basically we can have a map. Okay, so in the map we'll have maximum subsequence, longest subsequence ending with 7, that will be 1. And when 3 is here, will not put it into container. 3 will be in its own container now. Okay, alone. So 3 is here. Then when 5 is here, we'll check. We can put this here, right? So it will be 2. And when 3 again comes, we can see that there is no improvement in this, so we'll just not use it. Then when 6 is there, right? So for 6, we see that there is 5. We can extend 5 or 3. But maximum that we can get is 2. So 6 is ending at 3. And again, for 2, we do not have any element that can extend, that 2 can extend. So yeah, no. And then 9, the best possible the element is 6 there, so we'll extend 4. There's also a possibility of extending 7, but that will give you that will not be a maximum number value. So yeah, no. Also for 8 we can go 4. So the maximum from this will be 4 only. So yeah, map is there. But again, how? I think this is the right approach. Yep. And for every element, we will be storing the answer also, the maximum answer. Out. But the issue is that how do we get the value to extend? Like, for example, for 6 there are 2 options, right? 3 or 5. How do we check without running a linear loop, of course? Without running a linear loop, of course. How do we check that 5 is the best answer here? Okay. Okay. The thing is, let's say we have encountered 6, right? Let's say we have 6 in the array, and we have encountered 7, 3, and 5, and all that numbers. So we know that here our max longest increases of consequences 3 and 5 only, 1 2. So when 6 is there, what can we do? We can extend 3 or we can extend 5. But the thing is, if we extend 3, we are not including 5, right? But if uh, if we are extending from 3, right? If we are extending 6 from 3, and there is a 5 in between, then we are missing on a chance, missing on a potential subsequence element, right? Because 5 can also extend 3 and 6 can extend 5. So instead of getting 2, we are getting 3. So we don't need to uh, run a loop to check which has the highest number, because we know for a fact that whatever number is the maximum here but less than this will be the highest number, will be having the highest number here. Okay. See, for example, let's say I'm checking a random number 81654 something like that. Okay. So here this will be 1, this will be 1 because 1 cannot extend 8. Okay. 6 can extend 1, so it will be 2. 5 can extend 1, so it will be 2. Okay. And since we know that, we know the rule, right, that if we encounter a number that is less than this, basically in this collection we encountered 5 which is less than 6, so we can just pop it out and put 5 here. Okay, given the fact that there is no 5 here. Then we encounter 4 can also extend 1, and also we can do remove this. Okay, then here comes 2 can also extend 1, so this is, so maximum, the answer is 2 only. Let's take another number. What is the number? 73568. Maybe we have I need some number. Let's take another number. 2791345510, something like that. 2 will be 1, 7 will be 2 because 7 can extend 2, 9 will be 3 because 9 can extend 3. So we have in the container right now 2, 7, 9. Okay, we encounter 1, it cannot be it cannot extend anyone, so it will be 1 only. We have 3, so 3 can extend 2, so it will be 2. So ending any so maximum subsequence ending to with 3 is 2 only. Okay, so we can actually do like this. In the new container we have 2 and 3 right now. So, okay, so when we encounter 4, we check which is the basically the left, in the left what is the next greater element than 4. So we learn that it is 3, and yeah, if 3 is there, then okay, so there is a fact that if we have 3 1 2 4 something like this, then the answer will not be as simple as it looks. Okay, because if we rely on the fact that we have 3 here, so the answer will come from 3 only, so it will not. Okay, so okay. Hmm. So in this example we have 4, right? So 4 can extend 3 and we can put it into this container. So 4 will be 3, and for 5, again 5 can extend 4, so and we can put it into this container. So and 10 can extend 5, so 10 can be here. Okay, so whether 4 will extend 3 or not, it depends on the fact that it depends on whether 3 is present in this container or not. So for example, if 3 1 2 is 4 is our example, then first we'll have 3 in the container, then the moment 1 comes, will will what do you say, will discard it. Okay, then 2 will come here, and then our 4 will come here. So we need to put elements in this container very smartly, I think. So it should not be the case that for example, if we have 2 3 1 5, again this one will be in container, this one will be in container. The moment 1 is there, we need to empty the whole container, and then the 5 comes, it will be 1 5. But our best answer was when we didn't include 1 in the container, and instead put 2, and instead stick with the 2 and 3 and then add 5. That is our best chance. So how do we so we need to have 2 checks, one for the container and one for the map that we will be having. So we'll check first here and then see what is the maximum answer, and then we'll save maximum with that. So we'll do upper bound, and then if we get a number which is the beginning, then we'll okay. So what I have in mind is that we have a map and a set, or a vector for that matter, because it will be sorted only, so it doesn't matter. Let's just say we have a set. So for every element we'll be storing what is the answer if that element, if the our subsequence ends with that element, what will the answer. Okay, what will the maximum answer? And set insert will have that maximum subsequence at for that particular element. So let's try to run this one. 3 1 2 4. Initially it will be 3 1. Insert also it will be 3 only. Then we encounter 1, so it will be 1 only. And since 1's position in this is the same as the beginning of the container, so we'll empty it and then put 1 here. Okay. Now we have 2. So 2, for 2 we can see that 2 can extend this container, so we'll put 2 here. Okay. And also the answer for this will be nothing but the size of container, so it will be this. We'll check whether by putting the element here we can get the maximum answer, or from the map we'll do a upper bound in map also. We'll do a upper bound map dot upper bound. We'll do a map dot upper bound with this element, and whatever we get we'll just do this pointer minus 1. This is a pointer, this pointer minus 1, and we will then get the value for the element that can extend, that 2 can extend. And if it is and we'll choose the maximum from that 1 plus whatever the map answer is, and whatever the container size is. And that will be our answer, and it will be stored in map. Okay, final answer will be also the answer will update. Okay. Okay, for set we'll use a lower bound, and then for map we'll use a upper bound. Okay, let's try this. Let's try this. Okay, so for we have a map, intent map, or we'll have a set also. Int, this is container. Okay, so for int I is equal to, or rather for auto I in V, we'll have answer here as well, and in the end we'll just print the answer. Okay, so for I, first thing we'll do is we'll check. What we'll check? We'll check if the set lower bound, that is container dot lower bound. How do we do lower bound in set? Lower bound in set C++. Star lower bound. Okay, we don't need star. Okay, so we have this auto CT as lower bound greater than or equal to. Okay, so if we do not get the end of the lower bound for I, if CT is not equal to container dot end, then we do nothing, we'll just continue. Else what we do, we'll container dot insert this element. Also what will we do? We'll also do a map check. If mp dot find this element is not equal to, no, not find, mp dot upper bound this element. Is not equal to this returns the then empty minus minus, and this is so convoluted, but I like it. And in the end we'll just put it. Yep, this is done here. And for the inserting part, okay, we have t minus minus, and in the end plus MP equals so MP of I will be maximum of 10. Now MP of I will be 1 plus 10, and answer is nothing but maximum of answer and MPI. Oh bhai, segmentation fault. I'm sure this is from here only. Just want to see the map real quick. Okay, we have an extra 1 here, but the answer is still 4 somehow. We should not be having an extra 1. Where is that one coming from? Okay. While we are at it, let's just see the container. And 8. Okay. So it is working. It is working. Okay, so container is kind of working. Can we see it at every like iteration? 7 then 3, okay, then we have 3 and 5, okay, then we have 3. Okay, we found if ct is double equal to count dot begin no if con dot count I, then in that case we'll just continue and we won't need these all things. Okay, and now 3 should not be there. Okay, 3, 5 and 6. Okay, then when 2 comes, 2 will be there, 9 will be there, and then 2 and 8 will be there, 2 and 8 again will be there, 5 and 3. Again, why 5 and 3? Okay, so the moment we found a number less than 7, we should automatically reject it, no? Okay, bro. We are choosing the best candidate for this element, and for this element, how are we choosing the best element? We're basically getting this element, and okay. So what what I have done here is, because it is the same lower bound stuff, but I'm ensuring that, okay, so main thing here is this insert logic only. Okay, so see, when we have this number and we have this number, right? So we have a map. Okay, this map contains the increasing subsequence, largest increasing subsequence. When 7 comes here, there is nothing here, so 7 will be 1 only. Okay, let me do it like this, and we'll insert, put it in the map. When 3 comes, the thing is, in this sequence the 3's position should be here. Okay, so since 3 cannot extend 7, right, 3 can only replace this, right? So what we can do is we'll find all the elements that is greater than 3 but having a value less than equal to its value, and we'll remove all that value. For example, this one, and then we'll put 3 into, like I did here. Then the next value comes 5. 5 can extend lower bound of 5 in the best, if you want to get the best candidate for it, then will get 3 and 5 can extend 3, so it will be 2 only. Then comes 3 again. Best candidate for 3 right now is actually no one, because if we do the lower bound then we'll find that it is the beginning part, so chances are that it is equal to this. No, it is equal to this. That is the only option. So we will not do anything. We'll just return 0. And will not even insert it in now. Then comes 6. Again, 6 can extend this. So it will be this. Then comes 2. For 2, there is no best option here. Okay. And also from here, it will also return the beginning element, right? So we will not, so the answer for 2 will be 1 only, but whether we insert it in the map or not, that depends on all the greater elements that are, all the elements that are greater than 2 but having having this less than equal to 2's value. So for this case, We need subsequence, right? So 2 has been included here, and then 3 will be removed. So our subsequence will be 2, 5, 6. Okay, that is kind of. So you see, this problem, this here has a lot of flaws. But we'll try to solve it in my old way. We'll do dp01 and then mp of v0 will be dp of 0. We'll have two functions. Which will capture the element and the map. Okay, so we need to find the lower bound in this, right? This is our best candidate. Again, we have a map insert in which we'll take the value and element and the value. And if you already have a value that is greater than or equal to this, we'll just return, else we'll just put the value here and we'll take the pointer to this for all the elements that is greater than this element and their score is less than this value. For all that we'll just erase those values. And then insert my memorization power is very strong. Yeah, what I wanted to do was this. For auto in empty cout I this first 7 3. Yeah, see this thing I was curious about this thing only. Okay, so it still changes, but it doesn't change the fact that the answer is still full. Okay, that is kind of insane. Again, I'm still very ashamed to have seen the solution and then solve it. Fuck, bro. The fuck. Oh, sorry. My bad. Done. We have question, but I'm not going to try this. I think this is it for today's stream, and whoever joined, I'm not sure anyone joined. but